Next up is multiplying decimals, multiplying sign decimals, because it will matter if they're positive or negative. So what I want to do is start with a problem. So let's go as an example to start this whole process. I want to multiply, and what I'm going to multiply is 0.67 times 0.18. Now, what I wanted to do is show you the way I was taught. Here's how I was taught to do it. A lot of things, when you taught those things in elementary school, a lot of times they teach you the process, but they don't really tell you why it worked. And I plan to do that here. But first, let me show you how I was taught. I would simply put the numbers and put my multiplication sign down, and I would ignore the decimals for now. Now I'll do this like we normally do. We go 8 times 7 is 56. I'll put should have been a 6 down there. So I'll put a 6 down there, but then I carry over this 5 and put it up top of the 6. Then I do 8 minus 6 is 48, plus 5 makes that 53. Now the next line, you started with a 0 because you're multiplying everything by 10. Okay, so 1 times 7 gives me 7, and then 1 times 6 gives me 6, and then I add these rows up. Carry the 1. So this is what my teacher did now. Let's take a look. We looked at the numbers again. We had 0.18, and what we did is she counted 1, 2, 3, 4. 4 total decimal places. So what we did is we took our answer, the 1206, assuming the decimal was after it, because I didn't have any decimals in here. And then what she told us to do, it was a she, by the way, I'm going to the left 4 places, so the decimal wouldn't go there. There's 1, there's 2, there's 3, and then there's 4. This is where the decimal would go. So our answer to this would be 0.1206. So basically we ignored the decimals till the end. Now here's the reasoning why it worked. Remember, we talked about the decimal places and their place values. This, if you look, the 6 is in the 10th spot and the 7 is in the 100th spot. So this is 67 hundredths. Similarly, 0.18 is 18 hundredths. Well, if you can say these things, you can write the decimal and fraction version of them. 67 hundredths is the same as 67 over 100. And the 18 hundredths is the same as 18 over 100. So when I multiply the two of them together, 67, or let's say 0.67 times 0.18, if you keep track of the fractions, they'll tell the story. 67 over 100 times 18 over 100. When you multiply fractions, of course, you multiply across the numerators and you multiply across the denominators. So on the top we got 1206, and on the bottom we get 10,000. So this is 1206 10,000ths. So with 1206 10,000ths, then we know that if you're going to have a 10,000ths spot, it needs to be in the fourth spot. That's the 10,000ths spot. The only way that's going to happen is if the decimal is in front of the 1. So that's why it works. This here moves the decimal 2 places. This here moves the decimal 2 places. Altogether, these 4 zeros are the ones responsible for moving the decimal to the left 4 places. Anytime you divide by some sort of a power of 10, you get that happening. A quick example: if I took 25 divided by 10, I get 2.5. If I took 25 over 100, I get 0.25 because that's 25 hundredths. If I do 25 over 1,000, I get 0.025. You see, the 5 is in the thousandths spot, and that matches. This 5 is in the hundredths spot, and that matches that we divided by 100. And then this 10, well, this 5 is in the tenths spot. So that's the reasoning why the decimal moves, and you can worry about the decimals at the end of the problem. Just count up however many you have and make it work. So let's do a quick example to exploit this. Suppose I'm doing 1.5 times 0.3. Well, what I do is I make note there is 1 decimal place, 2 decimal places total. So whatever answer I get, I am going to move the decimal to the left 2 places. So all I do is I do 15 times 3. You'll find that that's 45. I think most people could do that. Now with the decimal being after the 5, because it's like 45.0, go to the left 2 places, and the decimal belongs in front of that 4. So you get 0.45. So let's do several examples to show this off. Here you have 0.12 squared. Now you have to keep in mind that 12 squared is 144. This is one a lot of students know. But you may not know how many decimals you're dealing with unless you write this out as 0.12 times 0.12. Now you realize that you have 4 decimal places total. So that means I'm going to take the 144. So I'll only put the 144 over here, I guess. The decimal is normally behind it. I'm going to move 4 places to the left. 1, 2, 3, and then I have to do an extra one. That means to fill this empty spot in with a 0. So this is equal to 0.0144. So when you get that, you've got to fill the empty spot in with a 0. Next one, we have 0.0002 times negative 8307.5. And now let me throw this down. I know it's going to be a negative number because a positive times a negative, well, that is negative. Now let's count the number of decimal places we have. I've got 1. I've got 2. I've got 3. I've got 4. And there's 5. So 5 decimal places. Now all I'm going to do is multiply 2. Here's what I'm going to do. I'm going to do 83075 times 2. And then I'll figure out the decimals later. I'll move whatever I get, I'm going to move the decimal to the left 5 places. So 2 times 5 gives me 10. I'll put a 1 above the 7. 2 times 7 is 14, plus 1 is 15. I'll put a 1 above the 0. 2 times 0 is 0, but plus 1, I'll put a 1 down here. 2 times 3 is 6, and then 2 times 8 is 16. So I'll take my decimal at the end after the 0, and I'll move it to the left 5 places. There's 1, 2, 3, 4, 5. 1.6615. Now there's a 0 at the end. I don't need to include the 0 at the end because you can either have it or don't have it. It doesn't matter. If you have the 0 at the end of it, you will not get marked off. It is still correct, although it is completely unnecessary. Let's try 0.6 times 1005. So here I just have 1 decimal place. And so I'll just do 1005 times 6. 6 times 5 gives me 30. Put a 3 above that 0. 6 times 0 is 0, but plus 3 gives me 3. 6 times 0 is 0, and then 6 times 1 is 6. So you get 6, 0, 3. I'm not going to put the last 0 because what's going to happen is this decimal needs to come back 1 spot to after the 3. And with that, you don't have to write 0.0, so I'm just going to erase it off and just leave it at 603. Here I'll try 0.3 cubed. And, well, you know that 3 to the third, probably, you know this is equal to 27. But keep in mind, since this is to the third power, I'm going to have 3 decimal places total. Imagine it's multiplied all the way out. 0.3 times 0.3 times 0.3, and then you'll see the 3 decimal places. So we take our 27, put the decimal after it, and I'll move to the left 1, 2, 3, and we put the 0 in that place. So 0.027. Now, I don't know that I've covered it, but take this, 10 times 0.05. All the 10 does, if you look at it in terms of fractions, we have 10 over 1 times 5 over 100. If I cancel out 10, I'm left with 5/10, and so this equals 0.5. Notice when I multiplied by 10, I ended up moving the decimal to the right 1 spot. So this is obviously the opposite of dividing by powers of 10. Multiplying by them makes the decimal move in the other direction. So for example, if I took 100 times 0.05, I would move the decimal to the right 2 places and I'll get 5. If I take 1,000 times 0.05, I'll move the decimal place to the right 3 places and I'll get 50. If you keep going, so you see this only 1, 2, 1, 2, and then a third one. So you get the idea. Multiplying by 10, and why is it 3 places? Well, there's 3 zeros. Why is it 2 places? There's 2 zeros. Why is there 1 place? 1 0. So we're going to use that to help us with the next problem. Here we're going to do 10,000 times 0.01354. Now, if I do, this 10,000 is going to move decimal right 4 places, same as the number of zeros. So that means it's going to take this and go 1, 2, 3, 4, and we'll end up with 135.4. Example. Next one, I'm going to do 62,000 times 31. Well, the 3 zeros will move. When you're doing this, moving 3 decimals to the right, when you don't have a decimal to begin with, we'll simply add 3 zeros to the end of the problem. So I'll do 62 times 31. And let's see, 3 times 2 is 6. 3 times 6 is 18. So I got a 2, 2. I'll put a 1 above the 8, 9, and then a 1. So this is 1922. And then move the decimal to the right 3 places, because it would be here. Move it to the right 3 places simply means to put 3 zeros on the end. Let's exploit this a little bit more further. Let's mix some powers of 10 with some decimals and see what that does. So here I want to do 1,000,000 times 0.000001. Well, 1 times 1 is 1. So I know the answer will involve 1 somehow, but exactly how, I'm not really sure. Okay, so here's what we have. These zeros means 6 places to the right. But then there's 6 decimals after this one, so 6 places to the left. Notice they're slightly different here. This had 6 zeros. This had 6 places after the decimal. Slightly different. All right, anyways, my answer then, well, what happens? Moving to the right 6 places and then to the left 6 places is to do nothing. And all you get is 1. Let's try negative 1200 times 0.019. So what I'm going to do is 12 times 19. By the way, I know my answer is at least going to be negative. 12 times 19. 9 times 2 is 18. Carry the 1. 9 plus 1 is 10. And then 1 times 2 is 2. 1 times 1 is 1. It looks like we get 228. So what do we have? This decimal says these zeros tell me 2 places right. But then these tell me 3 places left. What's the net result for these two things? 1 place left. So that means I'll start here and I'll move the decimal 1 spot to the left to get negative 22.8. Here, let's do a combo one. 12,000 times 0.05 times 9.3. So let's see what we have here. I'm going to do 12 times 5 times 93 and worry about the decimals later. So first I'll start with 12 times 5. I won't spend much time there. That's 60. And then 60 times 93. I recommend if you have zeros in your number to put it on the bottom side, you'll do less work. As you'll see, my first row will be all zeros. Then I can immediately go to the next row. 6 times 3 is 18. Carry the 1. 54 plus 1 is 55. And then you just get 5580. So we're going to have 5580, but let's see how we did with our decimals. So right here, 3 places to the right, and then here and here, these two together make 3 places to the left. Well, once again, 3 places right followed by 3 places to the left. They cancel out, and we just get 5,580. Now we'll move on. Well, as you know, when you learn how to do multiplication, the next lesson will always be division, and that's exactly what we're going to be doing here. Dividing signed decimals. Let's start that off with an example. Some of this, I hope, will be a review. Let's do negative 6.7 divided by 2. Well, you know that when you take a negative number and divide it by a positive number, you end up with a negative number. So at least I got that. Now the way we do this, I'm going to do these by long division. That means we will place the 2 outside of the division, and I'll put the 6.7 inside. Notice I'm spacing this out. You want to get these digits exactly right, so don't mess around here. In fact, take this decimal and immediately carry it above the division bar. I'm going to line my decimals up exactly. This is extremely important. You mess these decimals up and you might as well forget the problem. It's a done deal. So let's start. Do like you normally do, just like you do 2 into 67. I'm going to do 2 into 6 goes 3 times. Now for the rest of the problem, you ignore the decimal except you keep track of the fact that it's here. So 6 minus 6 is 0. Then what do you do in normal division? You bring the next number down. I'm not bringing down the point, just the 7. Now how many times does 2 go into that 7? 2 goes into that 7 3 times also. 3 times 2 is 6. Now we don't stop here. Normally you'd say the remainder is 1 and all is said and done, but that's not how it's going to work here. We're going to keep going until I get no remainder, or till we start repeating. You'll see what I mean later as we do some of those examples. So what do? Notice that I'm allowed to add a 0 at the end of the decimal. I've spoken of that earlier, why you're allowed to do that. So I can take this 0 and bring it down after the 10. 2 goes into 10 5 times. Now you know you're done because the remainder is 0. So we get negative 3.35. Guess what? Maybe I didn't explain that. Let's see. Let's take a look. 0. I'll do probably. Why can you add zeros to the end of decimals? Well, I guess I'll show you why now. This is the same as 0.10. This is the same as 0.100. This is the same as 0.1000. Why? The key goes into is looking at the fractions. 0.1 is also called 1/10. But 1/10 is the same as 10 hundredths. It's like you multiplied the top and bottom by 10. Well, I could multiply the top and bottom by 10 again, and I'll get 100 thousandths. I could do it again. I'll get 1,000 10,000ths. So you can add zeros to the end of a decimal till your heart's content. That's going to be useful for some of the stuff that we're doing. Well, you saw it was useful for that last example right there. Just putting the zeros at the end will help you continue carrying on the division. Let's do another example. So that's going to come in handy as we do negative 101.4 divided by 13. And once again, a negative divided by a positive is negative. So let me put the 13 outside. Now do my 101.4, giving myself lots of space inside of there. Let's see, 13 does not go into 10, but it does go into 101. It goes into there 7 times. 7 times 13 is 91. 101 minus 91 is 10. Now I can bring down my 4. And 13 goes into 104 8 times. As a matter of fact, it goes in there exactly 8 times. So our answer is negative 7.8. Let's try negative 2.07 divided by negative 4. This time I don't need to put a negative sign out there because this is a positive number. So I'll put my 4 in front of the division. 2.07. I've stretched it out to make sure I don't mess up my decimals. I'll copy this decimal here, make it bigger. All right, now we'll work this like we normally do. Does 4 go into 2? No, it does not. It goes in 0 times. By the way, I could put a 0 in front of that decimal like I do anyways. I guess I do know it starts like this. Anyways, 4 then goes into 20 5 times. 20 minus 20 is 0. I can bring down the 7. 4 goes into 7 1 time. Subtract. And now it's all hope is not lost. I simply put a 0 after the 7 and bring that 0 straight down after the 30. 4 goes into 30 7 times. I'm going to increase this division bar as long as I need so that it holds the number. 7 times 4 is 28. And once again, I can bring down another 0. And then 4 goes into 20 5 times. Let's do 23.5 divided by 9. All right, let's see. 9 goes into 23 twice. And then I'll bring down the extra 5. 9 goes into 55. Oh, let me put the decimal here. 9 goes into 55 6 times. And I'll put a 0 after the 5. And bring down that 0. 9 goes into 10 1 time. And now I'll bring down my 0. 9 goes into 10 1 time. Well, you can see this is going to go on forever. when you were a student, this was probably the first chance you got to meet any version of the infinite. And that an infinite is a process that never ever stops. So, we can write this 2.611, and then you could put dots like that. Although your textbook, or if you take a test that's on the computer, that will not be considered correct, or it won't even let you put an answer like that. So that's not the answer that they'll put. The one that you'll want to do is this 2.6, and then put the 1, but put a bar over the 1. That bar means repeat. So this is what I was talking to make my bar a little better. 2.61 with a bar over it. That means these ones go on forever. While we're here, let's throw in something else. Let's round that last answer to the nearest 10th. So the answer we got was 2.61. I don't need to go any farther than that, although more ones are coming. It goes on forever. Remember, to round, we're looking at the 10th spot, so that's where the 6 is. And then we look at the number after it, and this number here, this number after it, is less than 5, so round down. And we end up with just 2.6. I can't make that dot look good. Okay. Let's try negative 12.7 divided by 6. That I know at least is going to be negative. And let's see, let's throw the 6 out front. 2.7. 6 goes into 12 twice. Subtract, you get 0, bring down the 7, put the dot. 6 goes into 7 one time. And now start bringing down zeros. 6 goes into 10 once. Bring down another 0. Increase this bar as you need. 6 goes into 40 6 times. Subtract 4. Bring down to 0, 0. 6 goes into 40 6 times. And by now I see the game. I see that these 6's are going to go on forever. So my answer is 2.116 with a bar just over the 6. Round that last answer to the nearest thousandth. So we had negative 2.11. It's going to be easier to do your thousandths if you write at least one more digit after the thousandths spot. It has 6's that go on forever. So let me circle. This is our digit. That's the thousandths spot. Then this 6 is more than 5, so round up. And we end up with negative 2.117. And you're doing your rounding. When you're doing your rounding, ignore the negative sign. It has no bearing on the rounding. let's do 5.45 divided by -9. And once again, here's a number that I know to be negative. And let's have 9 go into there. So the 9 goes on the outside. 5.45, spacing out as needed. Make this division bar long. All right, 9 goes into 5 0 times. Let me bring up my decimal here. But 9 does go into 54 6 times. When you subtract, you get 0, so we bring down the 5. This is where students get nailed. They bring down a 0 too quickly. Be careful. You brought down the 5. Now we're in a position now to say whether 9 goes into the number or not. After you bring down the number, you then ask whether the divisor goes into that number with the thing brought down. Here, I had a 0 there. I just brought down the 5. Well, enough talking. Let me just do it. 9 goes into 5 0 times. So now I bring a 0 after and bring it down. 9 goes into 50 5 times. 45 or 50 minus 45 is 5. Bring down another 0, and I've got a 50 again. So now you can see where this is going. We'll just get a bunch of 5s forever. So I'll get negative 0.60 and 5. Make sure your vinculum, sorry, the technical name for that bar is a vinculum, but make sure it is just over the 5. You don't need any more than 1 5. 1 5 is good enough. Let's round that last answer to the nearest thousandth. You should get used to saying it's thousand. Somehow make yourself say it so you don't forget that you're dealing with decimals. All right, so let's see what we had here. We had negative 0.605s, and the 5s went on forever. The thousandths spot is right here, and then the decimal after it tells us to round up. So negative 0.606. Well, now this is a little bit different. Here, we're dividing by a decimal. So when you go to set this up, you're going to try to figure out how many times 0.6 goes into 7. And in fact, that's, I don't know how many times that is, at least 10, maybe 11 times. But it's difficult to do this problem. This is unlike anything you've done before with this decimal out here. So we don't want this decimal out here. No decimal out front. I do not want a decimal as a divisor. So let me show you how we fix it. What we're going to do is I would like to take the decimal out of the 0.6. So I would like to move this decimal one place to the right to make it just a plain old 6. Well, the way you do that is you multiply it by 10. But the beautiful thing about fractions is that whatever I do to the denominator as long as I do the same thing to the numerator, it's still the same answer. So look what happens. Multiplying by that 10 moved the decimal on the bottom like we wanted, but it also moves the decimal on the top, 1 place. So what I see students do is this: 0.6 and then 7.62, and I say you move this one place and then you move this one place. Now, whatever you do, do not, under any circumstances, try to do this division with all this writing in there. You'll get it wrong. I've seen it too many times. I guarantee you will get it wrong. I want you to rewrite it, and if you simply write more, you'll do better as a student. Trust me. The inside became 76.2. So basically, you move the outside one place and you do the same thing on the inside. That's because I multiplied by 10 ultimately. That's why it works. Let me carefully put my decimal above the other one. Now 6 goes into 7 one time. 6 goes into 16 twice. Bring down the 2. 6 goes into 42 7 times. So this equals 12.7. Next one we have is 0.756 divided by negative 0.28. Well, we know the answer is going to be negative, and so the initial setup is 0.28 going into 0.756. So this decimal out here, I'm going to move 2 places, so I'll do the same thing inside. Ultimately, what you actually did is multiply things by 100 in the background. But this gives us, the actual problem I'm going to do is 28 goes into 75.6. And let's see, 28 doesn't go into 7, but it does go into 75 twice. And then I bring down the 6. How many times does 28 go into 196? Let's see, 5, 6, 7, 8. 7 times 28. Let me do some calculations. 7 times 28. When you first learned to do division, you had to do these calculations all over the place. 14, 19. Oh, isn't that sweet? It goes in exactly 7 times with the remainder of 0. So I can just put my answer of 2.7. Let's try negative 434 divided by negative 0.02. The two negatives will cancel, so I don't have to worry about that part. Now, since there's no decimal involved in the 434, let me put 0.0 because I'm going to be moving its decimal to the right. I go 1, 2, so I go 1, 2. And you know what that means. I've got to fill it in with a 0 into that spot. So we're actually going to do 2 into 4, 3, 4, 0, 0. And I don't think I need a decimal because I think it'll go in exactly. Let's start with 2 goes into 4 twice. 4 minus 4 is 0. I'll bring down the 3. 2 goes into 3 once. Then I'll bring 3 minus 2 is 1. Bring down the 4. 2 goes into 4 7 times. and then you get 0. So I can guarantee you this, the answer is not 217. Why? You have to keep maintaining the same way you were until you run out of all these digits. I have not utilized them all yet. I can bring down a 0. How many times does 2 go into 0? 0. I can bring down another 0. How many times does 2 go into that second 0? 0. So the answer to this is actually 21,700. Pay mind to what I just told you. I've seen many students forget about these zeros up here, and that's nowhere near close to the answer, of course. And it happens to those students who choose not to be very careful with their decimals. If you were careful with your decimals, seeing just a gap there before you were finished should indicate to you that more needs to be done. Next we have 0.09 into 6.058. Of course, I'm not going to do that problem. I'm going to move my decimal twice, once, twice, and we'll have 9 going into 605.8. So let's start. 9 does not go into 6, but 9 does go into 6D. It goes in there 6 times, 54. 60 minus 54 is 6. Bring down the 5. 9 goes into 65 7 times, 63. 28. Brought down the 8. 9 goes into 28 3 times, and now I'll start bringing down zeros and increasing the vinculum. So I'll bring that 0 down. 9 goes into 10 1 time. Bring down another 0. 9 goes into 10 1 time again. And we can see that this is just going to go on forever and ever. So our answer is 67.31, and there's a bar above the 1. For the last example, round the last answer to the nearest tenth. So what did we get for our answer? 67.3. I don't need to go any farther than that. I just need to cover one place past the 1 in question, and there it is. The 3 is in the 10th spot. That 1 says to round down, and we just get 67.3. Now, if all of that's not enough for one class period, check this out. A little going over the order of operations, just a few problems to remind you that these things are still valid no matter what math you learn. So you still have to remember PEMDAS for the rest of your mathematical lives. So let's start. These have an annoying terminology and always just says simplify instead of just like compute or something like that, but whatever. It's neither here nor there. What I have is negative 1.3 to the second power minus 6.4 divided by 4 plus 8.3. Now, according to PEMDAS, the first thing I should do is this exponent. Now, the negative will cancel out. Now, let me help you through it, how you can do it in your mind. 13 squared is 169. However, when you did 1.3 times 1.3, that was a total of 2 decimals. So my decimal should be right there. I moved it back 2 places. So all I did was this part first. Next, I should do this part here, the division part. So I'll bring this stuff down, and I'll do the division next. If you think about it, 64 divided by 4 is 16. So this guy right here is 1.6 plus 8.3. And now it's just a matter of going directly across. I should probably put equals for each of these things. I'll get, for this part right here, I'll get 0.09. And this ended up being very easy then, 8.39. Here we have 7 minus 2.1 squared divided by negative 9. I'll tell you the first thing that I can do is the following. 7 plus 2.1 squared over 9. Now for the 2.1 squared, I'm going to do 21 times 21. And let's see if I have this right. 2 times 1, that's a 2. So I have 441. Now remember, inside of this is not 1, but 2 decimals. So this is 7 plus 4.41 divided by 9. Now let's go ahead and do that. 9 goes into 4.41. Let's see, it doesn't go into the first 4, but it does go into 44, I think 4 times. Bring down the 1, and 9 goes right into it. So we have 7 plus 0.49, and that's just 7.49. Make my 9 look better. Keep messing it up. All right, let's see how this works. According to PEMDAS, I need to do the inside of here first, the parenthesis. So let's do this. I'm going to do 1.5 minus 0.86. So off to the side, I'll do my calculations. I'll do 1.5 minus 0.86. And as you know, I'll have to put a 0 after the 1.5. And I'll even have to borrow. 10 minus 6 is 4. I can't do 4 minus 8 unless I borrow again. So for that, I get 0.1 times 0.64 divided by negative 0.000, just 2 zeros, 2. All right. Now you have multiplication followed by division. So you do whatever comes first in that scheme. And the 0.1 is simply going to move the decimal to the left 1 spot. So I'll get 0.064 divided by negative 0.002. And, well, I know the answer is going to be negative at this point. So let me put that down. Now I got to do 0.002 into 0.064. So I need to move the decimal 3 places to the right for both. Oh, that's nice. Look what I get. 2 into 64, and that's just 32.